Number 5. Now this one's a little bit strange. It is related to number 2. I'll take us back up to number 2. You see how there's a binomial on the left side here? Well, now we have a binomial on the right side. Okay? So it's no different. You just take each term and you distribute it in. Now, I can either rewrite this problem with the binomial on the left side, or I can just deal with it the way it is. And that's what I think I'll choose to do. I'm going to take this 2x squared, multiply it there, and there. So that's my first step. 2x cubed plus 6x squared. Okay? I'm going to change a color now because sometimes it's hard to follow just the pencil writing. So I'm going to take this 5x and I'm going to distribute it. This is actually a green marker. I don't know if it shows up. Yeah, it shows up kind of well on the screen. So anyway, we're going to say plus 5x squared, and then plus 5x times 3, 15x. Okay? And then finally, I'm going to take the negative 2 and distribute it through. So negative 2 times x, negative 2x, and then negative 2 times 3, negative 6. And then, once again, I just look for like terms, and I see this 6x squared and 5x squared are like terms, and also 15x and negative 2x are like terms. So I'm just going to add these like terms together. 2x to the third plus 11x squared plus 13x minus 6. We are going to circle this and call it perfect. Okay? We need to go through 15. So here's the continuation of that page. We're going to be distributing the 8n squared through all three terms here. So we have 8 times 3 is 24n to the fourth minus 32n to the third plus 40n squared. And then I'm going to distribute the negative 1 see that? So essentially when you distribute a negative 1, and this is a special case, when you distribute just a negative 1, all it does is changes all the signs on the right side. So minus 3n squared plus 4n minus 5. Okay? And then look for common terms or like terms. N to the fourth, there is no other n to the fourth, so I just rewrite that. There is no other n to the third, so I'm going to rewrite that one. But there is another n squared, this 40n squared, and the negative 3n squared is going to make 37n squared. A positive 37n squared plus 4n minus 5. Okay, and although that's an extremely long answer, that's what we have this time. Okay, number 7. FOIL, because it's two binomials. So first, outer, inner, last. And you might not even use the word FOIL. You might just always use the word distribute, because that's what you're doing. You're distributing each term from the first polynomial into each term in the second polynomial. So here we go. 6p to the 6th plus 12p to the fourth minus 10p squared minus 20. And it looks like that one's finished. because there are no like terms. Number 8. Again, I'm just going to draw this out for a little while so that you know what we're multiplying. I'm going in that order. So if you get mixed up on what I'm multiplying together, you just rewind the tape and look at the direction that my lines are going in. I did from the -8 to the 6 first, then from the -8 to the 1. Then I go from 2 to 6, then from 2 to -1. And that's the process that most teachers are going to take, and most students should take that one as well, so that you don't get confused when you're looking up at the board and your teacher's work doesn't look the same as yours. But -8 times 6 gives us 48. So -48 r to the 5th plus 8r to the 3rd plus 12r squared minus 2. And there are no like terms, so we are finished. Okay. Move on to number 9. FOIL again. In this direction, remember. First, outer, inner, last. So positive 10z to the 4th, because 2 plus 2 is 4. And then minus 45z squared, it looks like. Then a plus 6z squared, then a minus 27. Now this time we do have common terms. We have this -45z squared and this positive 6z squared. So won't be long and we'll be finished. 10z squared, to the 4th. -45 plus 6 is going to be -39. -39z squared minus 27. Circle. We're done. Okay, now this is where people start getting confused. When you have two variables and you're multiplying through. So let's try to think about this as we walk through it. Okay, if I'm multiplying xy times x squared, there are some common bases. It's the x and the x, right? And remember, when you multiply common bases, you have to add their exponents. So if this has a 1 there, how many x's do you have when you multiply the x's together? You'd have x to the 3rd, because 2 plus 1 is 3, so x to the 3rd. But then you're still multiplying with that y. Okay, x to the 3rd y plus 2xy. Oh, I missed one. See how easy it is to miss it. See, there's a y there and a y there. So there's the 2xy squared. The y is squared, the x only has a 1 and that's power. Okay? I feel like that one maybe you could write an intermediate step, saying xy times x squared plus xy times 2y. And maybe that'll help you guys figure out that x to the 1st times x squared is x to the 3rd. So this becomes x to the 3rd y, just like we have. And this becomes the y times y is multiplied by each other. And remember that you want to put the coefficient first. So 2xy squared. Alright?